In the next set of videos, we're going to actually look at Desmos. So this is using technology. Okay, so I'm actually going to switch over to my little Desmos screen here. Is this even going to work on here, you guys? Ooh, kind of. This is as high tech as I get, okay? So I've already actually typed in the very first one. And you can use the function notation, or you could use y equals, or you could even just type in. Now, you would go to desmos.com and push start graphing. Notice that Desmos knows my name. That's because you can actually sign into Desmos. It's free. You can have it on your phone, your tablet, your computer. Go to the website. You can sign up for free. And then what's really cool is you can save all of your graphs if you want. Another really cool feature is, I don't want that anymore, is if I wanted to share this graph, I could push share and I could actually send a copy of the link to this graph. That's another nice feature. Okay, so once you type in your equation, then if you want to create a table of values, you press this little, what is that, gear icon? So you press the gear icon, and then you see you have options. That's duplicate, that's table. So I'm going to press table. It switches it over to a table of values, and what's really cool is it actually is giving me the ordered pairs that are here. So I can tap. You see that's a y-intercept. Here's some x-intercepts. Here's my vertex. Here's a symmetrical point. Okay, and we notice that because it's an x squared, it is graphing a parabola. Okay, so that would be the very first part. It's asking you to create a table of values and then to sketch your graph. So you could use that to help sketch your graph. You can also put in more values. So if you go to your table, let's say you don't want 0 or you want to keep it going, so you go 3, and then it gives it just, 4. It's just giving you, maybe you need a fraction, 8, I don't know. How do I do my fraction? I have to do divide. 8 divided by 5, 8/5 I could do. So I could put in any numbers, and then it's going to generate a table. It's just plugging those numbers in and spitting out values, okay? Any questions on that? That's Desmos. All right. The other thing that's really cool is I already put in this other line. So if I click on that, I don't have the line, but if I want to graph it, I press it. It's a different line here. Now, if I want to know when these two functions are equal to each other, let's say I want to solve. Oops, why is that not doing that? Maybe I have to delete that. Okay. If I click on those points of intersection, it's actually going to show me the 2 points where they intersect. And normally, typically, you'd have to do all this by hand, or if you use a graphing calculator, it's way harder. So that's why Desmos, we use it, we love it, okay? And then we could use that information to graph this. But I did want to show how we could solve. So the first part is use Desmos, graph the parabola, sketch the graph, right? Using the points. The second part is if we want to know, let's say we wanted to solve the equation x squared minus 2x minus 8, where is that equal to negative 2x minus 4? Now we could solve that algebraically, but using the graph, we could actually solve it. So I'm going to put the graph back up and see if I can do this at the same time. Kind of. I want to solve where h of x is equal to f of x. So by the way, this one is f of x, the line is f of x, and the parabola is h of x. So where are they equal? If we were going to solve where they're equal, where would you say they're equal at? X equals negative 2 and x equals 2. So those are the points of intersection. So on our solve, we would say negative 2 and 2 is where they're equal. And it would be better if I kind of probably should have put the graph on here so that I don't have to sketch it out right now. But if I want to know where is h of x greater than f of x, that's greater than, I could look back and remember f of x is my line. h of x is my parabola. Where is the parabola greater than the line? The parabola is greater than the line here and here. So we're using those points of intersection. Here's h of x where it's greater. You see h of x goes below the line here. So from -2 to 2, f of x is actually below h of x. So where is h of x, the parabola, greater than f of x? That would be from -infinity to -2, parenthesis, union 2 to infinity. Why am I using parentheses instead of brackets on the 2 and -2? Because it's less than, not less than, or equal to, or greater than, sorry, it's greater than, not greater than, or equal to. Okay, now we want to know, when is h of x less than or equal to f of x? This is saying h of x less than or equal to f of x, right? So if I look back here, remember that my parabola was what? H of x. My line is f of x. And I could have, by the way, I could have typed that in originally. I could have written h of x equals. It would accept that either way. So when does the parabola go below the line? Yes, say it, say it, say it. -2 to 2. Now, should I put brackets or should I put parentheses? Why brackets? Less than or equal to, so we would include those endpoints, right? Any questions about this so far? Wonderful.